All right, let's get started. Let me get the lights adjusted and whatnot. Ooh, there we go. All right, let me get this this PowerPoint loaded up. All right. All right, welcome back from Thanksgiving break, and welcome to the last lecture in the Freshman Engineering Seminar this semester. You'd have to be so happy about it, you know. So I trust everybody's doing well as you're closing out the semester. I know a lot of you are getting finished with solving the world's energy crisis with your wind turbines in Engineering 104, right? Let me go through a few quick announcements. We've got some housekeeping to discuss in regards to the final exam. I don't know if you remember, but I typically don't like to refer to them as exams in my courses. We have celebrations of learning, so we'll have that next week. But let me go through some quick announcements. So first off, as I'm sure you're aware, has been a somewhat theme this semester. I've been mentioning the student organizations that are available to engineering students. This is sort of my last pitch to all of you. If you're not currently involved with any of the engineering student organizations, I would urge you to try and get involved as much as possible. All it's going to do is add more stuff to your resume, make you look better in the interview process and what have you. And plus, it's a lot of fun. I mean, you get to do a lot of really nifty things, things like casting concrete canoes and whatnot, and Baja cars and things like that. So if you're if you're interested, you definitely want to check it out. I've got the contact info for all of the presidents of the respective organizations, so I urge you to check it out. Next, and I mentioned this before, but SAME ASC is conducting their apparel sale. It was going to close today, but they decided to extend it one more week through the 9th. So if you want some apparel, there's the link. Everything's done online, so you can pay by check or pay by debit or credit card. So you've got that. Since you're going to be preparing for the final, I've decided to cancel quiz 14. So this quiz that closed today at 11, that's your last quiz for the semester. Last thing, I do want to mention some remaining activities that are going to be going on for the rest of the year. First off, the Richard F. McCormick Annual Technical Conference is going to be early next semester. It's going to be on January 26th, which is a Thursday. I would really emphasize that if you've got time to go, or better yet, have time to help out with directing guests to the event or helping with attendance or anything like that, you'll definitely want to be there. It's a really good opportunity to rub elbows with some folks who may be offering you jobs and internships over the summer. So you'll definitely want to be involved in that if you can. Most engineering professors will excuse you from class if you're going to be involved in helping out with that. And I would contact Logan Stacks if you're interested. Theta Tau is going to be doing Rush for spring 2017. Just make sure you contact them if you're interested. And ASCE is going to be going to the Virginia's conference in April this year. It's at Old Dominion, so everybody will be at Virginia Beach, and that'll be a fun and exciting competition. Okay. I'm sure you all have seen the emails in regarding to course evaluations. I decided to go ahead and throw the instructions here now so that everybody would understand how to do that. Just real quick, you go to mymu.marshall.edu, log in and what have you. You go to student and then student resources and course eval. You're looking for this. It closes next week at I believe it's at midnight. If you have not already done so, I would urge you to please do that. I mean, at least from my perspective, I take the comments that I get from students quite seriously. I mean, I see it as our job to provide the best experience for you possible. So if you've got any suggestions for improvement or anything you'd like to see done and what have you, let us know. So because we really do appreciate that feedback. Last, let's talk about the final exam. So the final exam will be next week during class. We're not going to meet during finals week. So we will have the exam in class next week on Friday. As for the format, the final exam is going to be a general overview of topics that are going to be that we've talked about during the semester. Let me be clear. I'm not going to ask you what was on the third bullet point of slide 26 in week 4. Like that's not what it's about. Okay. Generally, if you've been paying attention and you've been taking the advice and the topics to heart, you should do just fine. The exam will be roughly 8 to 10 questions, and they'll be short answer. I mean, we're talking about at most a sentence or two, not the 5-paragraph essay. We're talking about really short answers. I've done this class before, and on average, it takes students about 20 minutes to complete the exam. It's not a particularly time-crunched exam. My big thing, make sure you're writing legibly so that I can read what you're writing, because that's going to be a component of your grade. Now, all of the quizzes that you've taken this semester are going to be posted to MU Online, so all the questions, all the answers, you've got all the slides, all the recordings and whatnot. If you give everything the good once-over and make sure you have a general idea of what's going on, everything should be fine. Does anybody have any questions at all? Anything I can do to allay any concerns? All right. So, like I said, there's not going to be a quiz this week, but that doesn't mean that this presentation may or may not show up on the final, so you'll definitely want to pay attention. Our last speaker, certainly not least, is Alan Bragg. He's a manager of customer services at Appalachian Power. And some of you might think, well, that's just for us electrical engineering graduates. No, not necessarily. You might be surprised at how many opportunities AEP would have, not just for electricals, but for civils and mechanicals as well. So you'll definitely want to take his presentation to heart. And with that, let's give Mr. Bragg a round of applause. Here's that. And then here's this. I'll get everything loaded up for you.
I doubt that I'll need this microphone, but I'll go ahead and put it on anyhow. As Dr. Michelson said, I am Alan Bragg. I'm the manager of customer services for Appalachian Power. I work in the Charleston office. I'm a degreed electrical engineer. I graduated from West Virginia Tech many, many moons ago. And I also have a master's in engineering management from Marshall. So very familiar with this school. Think very highly of it. First, let me talk a little bit about my company. American Electric Power, AEP, is an electric utility. We're headquartered in Columbus, Ohio. We serve portions of 11 states, about 5 million customers, 5.2 million customers, and we have about 18,000 employees. A lot of those folks are engineers. We own tons of power plants, coal-fired, gas-fired, solar, wind, hydro, any kind of nuclear, any kind of power plant that you could possibly think of. We own and operate that. We own and operate the largest transmission grid, the high voltage transmission grid in the country. The subsidiary company that I work for, Appalachian Power Company, serves customers in West Virginia, Virginia, and Tennessee, and we serve about 1 million customers. We employ engineers from nearly every discipline, and there's probably disciplines that I've missed on this list, but generally lots of electricals and mechanicals, chemicals, civils, environmental, industrial, nuclear. We are, as the final bullet said, we're just one big engineering company. Nearly everything we do has some sort of an engineering or computer science bent to it. I'm going to focus more on the types of engineers that would be employed at say, a coal-fired plant, because the majority of our plants here in the coal fields are generally coal-fired, and what we would use those particular folks for. Mechanical engineers, all of these thermal plants, whether it's coal or gas or whatever, have a thermal cycle associated with it. For a coal-fired plant, we burn coal, in a steam generator. It heats up the water within that steam generator like a big tea kettle, makes steam, and the steam in turn turns the turbine. Okay, so, and the turbine turns the generator, of course. So the mechanical engineers that we would use in those plants generally would be a part of the thermal cycle. Electrical engineers, lots of motors, lots of controls, lots of protection and control systems. I was lucky enough to start my career at a power plant, and I really learned a lot. I can remember being in this same exact type of a format when I was a freshman engineering student, not having any earthly idea what I was supposed to be doing when I got out into the real world. Frankly, the reason I became an engineer was because my dot on a aptitude test put me near an electrical engineering dot, so that's the reason I ended up where I am. Not because I knew this is what I wanted to do, but it's turned out really, really well. Walk into the power plant, everything is huge. You know, there's bolts and nuts that are this big around that you have to operate with a sledgehammer. So lots of interesting things for a young, wide-eyed engineer to see and learn. So I felt very, very fortunate to be a part of that. Chemical engineering, we do a lot of water testing. Anytime you have a steam cycle, there's lots of water. It's got to be extremely pure in order to not corrode the systems. So it's got to be more pure than the water that you drink. Fuel testing, BTU quality ash, all that kind of thing. Lots of environmental engineering, air and water quality from the plants, monitoring of stack emissions, monitoring of water outputs to make sure that it meets all the standards. Civil engineering, mostly involved with the design of new plants, foundation and structural type issues. Generally, you wouldn't see a civil engineer working day-to-day in a power plant, but they would be involved in the design of the structure. Nuclear, generally at nuclear plants, that's the only place. Now, one thing that you got to realize, and I'll say this with all confidence, we're a 100-year-old company. This industry is 100 years old. So the vast majority of all the actual hardcore engineering has been done, okay? So there will be lab coat engineers that sit around designing things, but the vast majority of engineers in the field and in the plants are going to be associated with day-to-day operations, troubleshooting, problem solving, project management, and then ultimately supervision and management within the company. So, you know, don't assume that you're going to have to carry your calculus book with you every day on the job, because frankly I've never opened one since I joined the company, and the vast majority of folks won't either. I will tell you, if you've got any questions while I'm going through, please feel free to ask. Transmission, I told you that Appalachian Power and American Electric Power are in the largest transmission grid in the country. We employ a lot of civil engineering folks. Each one of these towers is an individually designed tower based on the geography, the load carrying needs of that particular tower. As you can see, the legs on the towers in West Virginia aren't always square, so there's a lot of foundation design, there's a lot of tower design in those. The strength, because some of the spans of wire are a couple hundred feet long, and others are 1,500 feet long, spanning a big valley. So there's a lot of engineering that goes into these structures. Once they're done, though, the civil engineer's job is done, and they move on to the next project. Electrical engineering, they do a lot of load studies, how much current they need to carry in order to supply the load that's connected to that. Protection and control, you want to make sure that if you have any kind of a fault, a short circuit condition within that facility, that the proper breakers trip, okay? The worst thing that you can do is not operate your system or not open breakers when you have a faulted condition, because what you end up doing is burning things down. And so that's not good. Our system is, our transmission system is generally self-healing. So if you have a transmission line that's got breakers all along it in the individual substations, those breakers will figure out where the faulted conditions are. It'll trip and lock out the transmission lines in that area, keep everything else in service, so that you have fewer customer outages than you would otherwise. So protection and control is a very important part of what electrical engineers do for us. Sizing wire to make sure that it's heavy enough to handle the loading. Environmental, generally we use environmental engineers when we're constructing new facility. Environmental impact studies, BAT studies, water quality studies, et cetera, et cetera. These days, you have to be very careful when you're involved in a construction project, and so we have the environmental folks that are looking over our shoulders and making sure that we're doing what we're supposed to do. Substations, as the picture depicts here, we have them everywhere. We have transmission substations that are they're no more than switching points. We have others where we step down the voltage from a high voltage like 138,000 volts down to something that's usable within the specific areas like 12,000 volts. The substation that serves this campus is 2 doors down. It's called our East Huntington station. So what kind of engineers would we use for this type of work? Again, civil engineering for structure, foundation design, spill prevention. Like anytime we have, that's a substation class transformer. Anytime we have one of those, they're filled with oil, so we've got to do spill prevention dikes. We want to contain every drop of oil in case that transformer would break down and fail. Electrical engineering, again, equipment sizing, load studies, P&C, testing, project management. Environmental, again, engineering, siting, environmental impacts, things like that. Distribution, that's the department, that's the group within the company that operates the systems that are in your neighborhoods. The lower voltage items like the pole that this fellow is climbing here. We generally only use electrical engineers for this type of work. Most of the other engineering discipline issues have already been pre-engineered, and we know our engineering technicians know what size of pole that they're supposed to put in for a variety of applications. So all that engineering work's done. But again, equipment sizing, protection and control, load flow studies, the distribution circuits that go throughout the areas, they'll go as far as their capacity will allow them to. So if I've got a circuit that's in downtown Huntington, it might be a mile long, okay? Because I've got enough load in that mile to take up the entire capacity of the circuit. So that's very simple from a protection and control fusing standpoint. However, in rural areas, I might have circuits that have 300 miles of line on it. There's a couple of circuits that we have in some rural parts of West Virginia that literally have 300 miles of line. So you have to have not only the station breaker, but you also have to have line reclosers, which are basically breakers that are hung on the poles. You have to have fusing and all sorts of other things. Our system on the distribution is not self-healing like it was, like I mentioned on the transmission. It is, they're generally radial. Our protection and control systems are designed to help with troubleshooting. So generally if we have a fault like a tree on the line or a bird or a squirrel or whatever, you want the protection and control device immediately upstream from that fault to trip. That way when our line guys go out to patrol the line to determine what the reason for the outage, they'll know when they see a recloser, a line recloser tripped, that they just need to look immediately past it to determine what the cause is. So instead of having to patrol 300 miles of a distribution line, maybe they only have to patrol 2 miles before they find what they're looking for. So it helps to troubleshoot if you get the protection and control correct. Again, lots of project management, lots of operational responsibilities. and leadership responsibilities within the distribution organization. Any questions up to this point? Okay. This isn't really what I was asked to talk about, but it is a hot topic these days. And my guess is that there are a number of you in this room who may be very interested in environmental type issues. Just tell you what we've done. As I said when I first started, we have all types of power plants. And here in West Virginia, because we are a coal state, you locate near, whatever your fuel source is, that's what you do. So if I'm in Canada and I've got lots of available water, I might have a lot of hydroelectric dams, right? So if I'm in the Midwest or in Texas and I've got an abundance of natural gas, then most of my power plants are going to be natural gas. Well, we're in the middle of the coal field, so the abundant fuel for us over the years was coal. And I can tell you, based on my experience at the power plants, that we have installed a lot of emission control equipment over the years. We installed precipitators in the early 70s that would control and remove the particulate matter from the emission stream. So that was the first that we did. More recently, about 10 years ago, we installed flue gas desulfurization units on all of our supercritical power plants. And supercritical it's a steam cycle where the water flashes directly to steam without boiling. So on our large supercritical plants, we installed scrubbers, and those scrubbers will remove 90+% of all the sulfur oxides, the nitrogen oxides, and mercury from the waste stream. So plants like our Amos plant, which is the top right corner, Amos is located in St. Albans, right? You can see it along Interstate 64. That's a scrubbed plant. So you will see clouds coming out of all the stacks there. The tall, skinny stacks are it's the flue gas from the steam generator. With the exception of just a tad of the non-removed SO2, NOx, etc., the vast majority of everything coming out of those stacks is water vapor and CO2. The three large, the fat, short stacks on the right side are cooling towers. Those are hyperbolic natural draft cooling towers. Everything you see coming out of that is going to just be water vapor. That's a part of the thermal cycle. So what we end up doing is they make steam in the steam generator, run it through the turbine to make electricity, and then they'll condense it back down to water to run it back through again. The way we cool that water down to make it condense from steam to water is with the cooling towers. So that's all water vapor there. We spent about $5 billion on the scrubbers for Amos plant, Mountaineer plant, which is up near Point Pleasant, and the Mitchell plant, which is up near Wheeling. The smaller, older, subcritical plants, those plants where the steam cycle involves a boiler, basically you run the water through the steam generator, it goes into a drum and it boils off and makes steam. Those plants, you can't make a financial case for adding scrubbers to those plants. The finances just don't work out, so we closed down 3 of those older plants and converted one of them to natural gas. And then to replace the rest of the generation, we bought a combined cycle gas unit to replace the generation. We are investing in a ton of wind. We have contracts with wind generation providers to provide, I think it's about 300 megawatts of wind generation to our customers in Appalachian Power. We are going through the contracting stages right now to actually install our own company-owned wind generation. We do not have any solar yet, and I'll tell you, up until just recently, you probably find this hard to believe, but up until just recently, it was cheaper to generate electricity with coal and natural gas than it was to generate it with wind. Now, I know that is counterintuitive because you don't have to have the fuel for wind, but the installed capital cost of wind generation caused it to be more expensive than coal or gas. But now, just recently, it's in the money. So we're in the process of building those plants. I mean, and let me kind of stop there just for a second and say, we as a utility are responsible not only to provide electricity to our customers, but we're responsible to do it as cost effectively as possible. So even if we wanted to shut down all the coal and all the gas in order to focus primarily on wind, you really can't do that because the regulator, the folks who regulate our business and set our rates, they will always ask you to do things as inexpensively as possible. So, so that's what we try to do every step of the way. So, solar isn't there yet. I know there's a lot of utilities that are installing solar. I know that there's a lot of individual companies and residential folks that are installing solar. The cost structure is not there yet. It doesn't, at least in this area. I mean, if I was in Arizona, yeah, I'd do solar. But in West Virginia, the cost structure doesn't make sense yet. It's getting better and better and better, and I think we will eventually get there. I think we've got some planned sites that we'd like to see solar developed on, but just not there yet. The second thing about renewables, solar and wind, I mean, this is kind of logical, and you've probably heard it before, so I'm sure I'm not bequeathing any big magical information on you, but wind only generates when the wind's blowing, right? So you can't turn a windmill if there's no wind, and solar only operates and generates power when the sun's shining. So regardless of how far we get along in the implementation of renewables, there will always be some sort of fossil fuel or nuclear generation that's there to provide electricity when neither of the renewable types are available to generate. Any questions or comments on any of that? Yes? Wind turbines, there are about, I think they're about $2,500 per kilowatt. So generally one of those is about 1.5 megawatts or 1,500 kilowatts, okay? So, you can do the math there. But that plant, so one of those is 1.5 megawatts, right? That plant right there is 2,900 megawatts. So you can see that there's a huge difference, meaning you've got to have wind turbine after wind turbine after wind turbine in order to, so you'd have to have 2,500 or 3,000 of those wind turbines to meet the output of the coal plant. Plus, they only have, the production factor is about 14–15%. So for every 1.5 megawatts of wind production, the output is only 14% of that. So it's not very efficient. Whereas the coal-fired plants, and I'm not trying to sell you on them, I'm just telling you that's the cold hard facts. You're gonna have to have these guys, even if you have lots of those guys, okay? Any other questions? Yes?
What is the middle picture? Is that
That's down into a stack. That's an aerial shot down into a stack.
one of the thinner ones on top?
Right, yep.
And you mentioned that they cool
the short fat ones on the right.
Okay. Is that,
See, everybody looks at one of those and they think it's a nuclear plant, but it's not. It's just a cooling tower. Go ahead.
is, but the water vapor coming out of it, that is, I mean, is it cooling as it goes up and then the water is collected and reused?
Well, they're two separate systems. The water that you use within the thermal cycle is contained and it goes out. It's like a heat exchanger.
Oh, okay.
Basically, it goes out and we pull river water into basins underneath those cooling towers
Okay.
and then pump it up down over and it evaporates, and when things evaporate they cool, right? So they evaporate, cool, and let off the heat in the form of water vapor.
Okay. That makes sense.
Any other questions? Okay. We, meaning Appalachian Power Company, have a very robust energy efficiency program. We offer rebates for energy efficiency type projects that commercial and residential customers want to undertake. Lots of those surround lighting projects. These lights here are LED lights. They're very efficient. 15 years ago, that bulb right there would have been a probably 150 watt bulb. This is LED, so it's probably 20, 25 watts. So you get a lot of bang for your buck on energy efficiency type projects, especially lighting. Our load, for example, we believe that our load is decreasing over time because of energy efficiency projects. What that means is you need to build fewer power plants. So we undertake these type of programs to reduce the need to build additional plants. We do heating and cooling type projects. We will do energy efficiency studies within homes. We will send contractors in, and they will look to see if you've got leaks around your windows. They'll show you what to do to repair those. They'll provide things like low flow shower heads and that type of thing. So complete energy audits. We also participate in one-off customized programs with industrial customers and large commercial customers. So if one of these folks comes to us and says, hey, we want to change out all of our motors from 1950s vintage motors to new high efficiency motors, we would offer incentives and rebates to help them do that, because we think all those things make sense for us, for our customers, for the environment, for the states and the country, and we just think it's the right thing to do, so that's what we do. Any questions on those programs? Okay, I think that's my last slide. So, Dr. Michelson, anything else you want me to talk about?
One quick item, if you can. I know that the folks in this room are probably thinking job, internship,
Yep.
Summer co-op, or anything like that. Do you have anything you can tell them in terms of potential employment opportunities, both after graduation and while they're here? Anything specifics you can give?
We don't really do internships these days. We don't do co-ops these days. But I'm 54, and I'm amongst the youngest engineers that we have on staff. So there's probably some good opportunities for advancement coming out of school. Again, we employ tons of engineers, and we're all getting older every day. People retire every day, and we're at a staffing level now where we're like most organizations. We're staffed at about the lowest level that we can possibly operate and still survive. So when an engineer retires, or when a manager retires, or whatever, we are filling all of those positions. In fact, I have one of my employees that tells me he's going to retire in the middle of next year. So there's a lot of other folks. Again, we serve We serve parts of 11 states, Virginia, West Virginia, Tennessee, Ohio, Indiana, Arkansas, Oklahoma, Louisiana, and Texas. So if any of you are from any of those places and you're interested in going to work for an electric utility, we're in all those places. I can tell you, I've been with this company for 30 years. I have never missed a paycheck. Okay, I'm not trying to recruit. I'm just telling you this is the fact. I've never missed a paycheck, with the exception of times when we've got major storm trouble and it's all hands on deck. Most of the days I'm home at 5:30, 6 o'clock every evening. Benefits are as good as you'll find anywhere. The pay is equal to any other industrial that you might go to work for. And I would expect that all electric utilities and other utilities are exactly the same as that. So I've never looked back. I was very pleased to have the opportunity to come to work for this company, and I've never looked back, and I've never second thought my decision.
I do have one more question.
Okay.
What are your thoughts on licensure? Does that help with the job at that AEP, getting your stamp?
Yes, always. It's as I said earlier, a lot of the design engineering has been done already. If you're a civil engineer and you're involved in the design of towers or structures or foundations, it's mandatory that you be a professional engineer. As far as the electrical side, not really so much, because we don't do a lot of electrical design. It's just pretty much plug and play with what we've already got. I will tell you though, having been a person that made a poor decision when I was 22 years old or 23 years old and did not go and get my PE. So I'm not a PE. I wished my entire career that I had, when I still had the knowledge that was required to do it. There's no way at this point in my life that I could pass that test. So I'd encourage you to do that as soon as you possibly can. As far as progression within grade within this company, in order to get to the highest pay grade, the highest level pay level or structural level, it's required for a staff engineering position. It's a required. You have to have a PE.
Does anybody in here have any questions or remarks, anything at all?
We love hiring people fresh out of school, and the reason is because we kind of like to get folks before they have had other experiences, so that we can train them to do the things that we want them to do. Nearly everybody that I ever came across with this company were hired directly out of college. Yeah, that's what we like. You know, we don't, because we don't have, you mean geothermal engineering or geothermal generation? Right. We don't have any naturally occurring geothermal structures and formations around here. There's a lot of that in Iceland and places like that where they have natural springs, and yeah, it's good, it's cheap, it's very abundant generation if you haven't. It's possible. It's possible. You know, we did a lot of geothermal residential heating and cooling several years ago. Geothermal heat pumps. They did a lot of that, and really you just have to dig 100-foot wells, and you're pretty much golden. Yeah, very energy efficient. It is. Thanks for asking. Well, since I guess I'm the only thing standing between most of you and lunch,
I do have a couple of closing items. First off, let's give Mr. Bragg a round of applause.
Thank you.
Let me get that. All right. I can tell that probably a lot of you were happy to hear that you wouldn't have to carry your calculus book around during work. I know some of you that are in calculus have probably hit your limit with that stuff. Limit. Be prepared for that if you ever have me again. A lot of very bad, cheesy jokes. Just a few final housekeeping items. Again, all of the previous quizzes will be uploaded to Blackboard. Don't forget to listen to the recordings and whatnot. Our exam next week, just come in like you would normally. The exams will be ready to go. Just go through the notes, go through the quizzes, and you'll be good. Don't forget your course evals, which will close next week at midnight. On a final note, in my opinion, I think it's the purpose of this class to help you all find your passion, whatever that is. Now, I'm full aware that some of you have negotiated this class and thought, hey, maybe engineering isn't for me, and that's totally fine. Again, my goal is to help you all find what it is that you're passionate about, and hopefully this course has done that and helped shed a little bit of light on what it actually means to be an engineer and practice engineering in a number of fields. I'll be completely honest with you, if you are an electrical engineer, this will probably be the last time I have you in class. But if you're a civil engineer or a mechanical engineer, there's a good chance you will have me again. And I look forward to having all of you in class again if possible. On one more final note, you all have my contact information. If you ever have any questions, concerns about engineering, you just want to stop by and talk, my office door is always open. With that, I am going to shut up and let you all get out of here. We'll see you next week for the final.